The standard is 8.EE.1, note and apply the properties of integer exponents. And our essential statement says I can use the negative exponent property. This is the last exponent property that we will be learning, and it's the negative exponent property, which some people think it may be the hardest one. So I'm going to go ahead and show the rule for this property, and we'll go from there. Okay, the negative exponent property states that any base a to the power of negative m is equal to 1 over a to the positive m, and also 1 over a to the negative m is equal to a to the positive m. So we like to have our simplified exponential expressions with positive exponents. And the way that you get those positive exponents is by using this rule. So the shortcut, or the simple way of finding the answer, or the simplified answer I should say, is if you have a negative exponent, all you do is you move that negative exponent to the other side. Okay, so if it's in the numerator, you move it to the denominator and you make it positive, or if it's in the denominator, you move it to the numerator and you make it positive. So move it to the other side and make it positive. We'll do a couple of examples. So let's say we have our base v to the power of negative 3, okay? Here our negative exponent is in the numerator. So all we're going to do is we're going to move it and make it positive. So our simplified answer is 1 over v to the positive 3, okay? Let's say we have 3 to the negative 7. Okay, well, again, our negative exponent is in the numerator, so what we're going to do is we're going to move it and make it positive. Okay, how about if we have 1 over 4 to the negative 2? Now our negative exponent is in the denominator, so we're going to go ahead and move it and make it positive. And you're like, where does this 1 go? And why is it not a fraction? Well, technically it is a fraction, it's just over 1. Somebody asked me, well, what if we don't have the 1 in the numerator? What if we have like the number 9? So let's say we have 9 over c to the negative 2. So the 9, it has a positive exponent, so we just leave it. You leave anything that has a positive exponent. And the c to the negative 2 has a negative exponent, so we're going to go ahead and bring it to the top and make it positive, and that's actually our answer right there. Remember, numbers go before variables, so that's how you would write it. All right, let's do a couple more challenging examples. Let's say we have x and y to the negative 3, and I want to simplify this exponential expression with only positive exponents. So all I do, first thing is first, okay? I'm gonna go ahead and draw my line for my fraction. Because most of the time when we have negative exponents, our answers will end up being fractions. And then I look at all my different bases. My first base here is x. The x, when you don't see an exponent, the exponent that is really there is 1. So the x actually has a positive exponent of 1. So I'm not going to move it anywhere. I'm going to keep it where it is. And then I'm going to go on to the next base, y to the negative 3. Well, that is a negative exponent, so I'm going to go ahead and move it and make my exponent positive once I move it. Now the x and the y, they're different bases, so I can't do anything else, and that is my answer. X over y to the positive 3. Okay, well, what if I have something like b to the positive 8 over b to the negative 3? I'm going to go ahead and start this off again with my fraction just in case. And then I'll go ahead and work with every single thing that we have in this example. So the first thing we have is b to the positive 8. Well, that's a positive exponent, so I'm not going to move it anywhere. That's going to stay in the numerator. And then I move down to the next thing, b to the negative 3. Well, that's a negative exponent, so I'm going to go ahead and move it. I'm going to move it to the top and make it positive. Normally, I would say, okay, well, we're done because now everything is positive and I'm good to go. But if you notice, we have the same base. When we have the same base, we can keep simplifying it. And this time, we can use our other properties to simplify this exponential expression. Here we have b to the 8 times b to the 3. So to simplify that, that equals b to the 8 plus 3, which is 11. And that is our final answer. So remember, you can keep if you can keep simplifying it, then keep doing so. If you have different bases, like right here, you can't simplify further. All right, let's do 2 more examples. Here we have 2 to the negative 3 and n to the positive 7. I'm going to go ahead and write down my line for my fraction just in case. Notice over here we didn't actually use the fraction. This is really over 1, but we don't write over 1. Okay, 2 to the negative 3. Uh-oh, that's a negative exponent. I'm going to go ahead and move it and make it positive. And then n to the 7. Well, that's already positive, so I'm going to leave it where it is. And you're like, okay, well, n and 2, they're 2 different bases. We can't do anything with that. You are absolutely correct. And normally I would say, okay, we're done, but 2 to the positive 3 is a very simple thing to do in your head. So if it's something simple like 4 squared or 5 to the power of 3 or 8 squared and things like that, go ahead and simplify those numbers. So 2 to the power of 3 is actually 2 times 2 times 2, which is 8. So I'm going to go ahead and simplify that to n to the power of 7 over 8. Again, only simplify answers when they're easy to do in your head. If it's something crazy like 3 to the power of 15, obviously don't do that in your head. Just leave it as it is. But if it's something like this, 2 to the power of 3 or 7 squared or something like that, then please simplify your answer. All right, last example. Z to the power of negative 5 times z to the power of negative 10 over a to the power of negative 2. I'm going to go ahead and write my line, and I'm going to go ahead and start with every base. So z to the negative 5. Well, that's a negative exponent, so I'm going to go ahead and move it to the denominator, make it positive. And then we have z to the negative 10. That's also negative, so I'm going to go ahead and move it to the denominator and make it positive. All right, so we're done with this and we're done with that. All right, and then let's go on to a to the negative 2. Well, that's a negative exponent, so now instead of keeping in the denominator, I'm going to go ahead and move it to the numerator and make it positive. And I'm done with that. Okay, we're almost done. If you notice, in our denominator, we have the same base, z, so I have to simplify that. Z to the power of 5 times z to the power of 10 is really z to the power of 15. And then we have an a to the power of 2 up here. And we're done. It's important that you know, if you can simplify something, please do so. If you can't, then leave it as it is. If you have any questions, please let me know.